Hey everybody, this might be a little long. Got some really strange things going on here with this circuit, and figures that thing turns on every time I go to talk. Strange things that I want to show you. This is the Overdriven tate using a small ballast to drive the tate. I got these new spark caps in the mail today. They work pretty good. They're 300 volt, 20 amp. And they seem to work really well with this setup without getting too hot or breaking down yet. Got 3 just in case. Anyway, 20 microfarad series reactance bank off of the tate output in series with the ignition coil. And the output of the ignition coil is just going to some condensers, and we're discharging the spark from those. That is really immaterial to the operation here that we're about to see. So, what I want to show you is this is 120 AC coming in. I'll take very particular note of the configuration. That's the black wire coming off of this little fancy power cord port there. I don't know if you can really see it in there, but it was pre-wired from the factory. I just scrapped it out of something. I already had the black and white wires on it. So I am absolutely positive my hot wire, which I'm also using a grounded plug, so I know my configuration is correct. That black is 120 positive, and it is being switched. Okay? Now, we turn the switch on, and it behaves just like it always has. The spark works pretty good at, you can even see it flashing here, maybe. Well, when it's dark, you can see. Yeah, maybe it is. There it is. Every once in a while you can see it. The camera's not picking it up. But it is sparking, it's working great. What it's doing is it's directly shorting the output of the tate, collapsing the field of the coil, discharging the reactance bank into it. Consequently, or alternatively, the same gap directly across the reactance bank, shorting it, produces the same, if not stronger effects. Also, besides the point. So, it's collapsing. We're getting arcs. You can see there coming off. Not significantly high voltage, maybe about 10,000 volts, but higher amperage because of the capacitors. I can get a good arc out of that. It comes all the way down to the terminals. So power output isn't really of a concern here. What I'm going to show you next is that when I turn off the switch here, which should be breaking the hot wire to the circuit, now I'm going to discharge the reactance bank. Okay, nothing going on there. And it discharged the storage bank, which also gets discharged when I do the reactance bank. So shorten all the terminals of the tate here, so that there is no stray voltage anywhere. Okay, nothing. Okay, they're all shorted. Now, technically, all we have hooked up here is this is still plugged in. And before we were reading a load on here, obviously, because we were loading the ballast was very wastefully loading the circuit. Now, potentially, the only thing hooked up is the neutral wire, which is the white wire there coming through, and it's going to the white wire primary input of the ballast. Secondary of the ballast is what's feeding my tate circuit. So I've got the 2 legs here tied together for 2 different bulbs, and then the common ground here going to the ground of the tate. Now, what I noticed is when I take an earth rod and touch it to, I'm going to turn this back on and show you first. I'm going to touch it to, notice the frequency that the spark gap is firing at. I'm going to now take the earth rod and touch it to one particular side, and the frequency practically doubles. So somehow this earth rod is creating a much higher negative potential on this negative side of the tate output, allowing the breakdown voltage to happen faster. So I'm going to turn it back off. With that in mind, I noticed that I could put it, let me short this out again. I noticed I could put it in a lot of different places and have the same effect occur. I could put it on this side of the reactance bank, the side between the capacitors and the coil, and there's a very large current that starts manifesting here. You can see the the arc's coming from it. It does increase the, I see sparks coming from it and so forth, which is expected because that's potentially 1,000 or 2 volts coming out of there. So we're going to see a little spark going to the earth rod. So discharging again. Okay, I'm going to do every terminal of the tate to show you this here now, just to make sure. I think that's all of them. Anyway, oh, that one. Okay, now, just the neutral wire is hooked up because the switch is off. Brand new switch, no broken, corroded, stuck together contacts or nothing here. We have this ground wire. I'm going to take this ground wire and I'm going to run it through a resistive load to the dual output of the secondary of the ballast, which is somewhat insignificant, but just for this demonstration, I'm going to show it to you this way. What I'm going to do is I'm going to turn it on first, and then I'm going to hook it up here and show you. Nothing happens, okay? So that's hooked to the, this is rated at like 35 to 250 volts AC. So the switch is on, the tate's operating normally, spark gap's firing, we're getting oscillations. However, when I turn the switch off, that it breaks the hot wire and allows just the neutral to be hooked up, something very strange happens with this ground wire coming off the secondary of the ballast. The light comes on. Now what in the hell is that all about? So, it seems like now electrons are able to come from the earth rod through the light, power the load, go to the secondary output of the ballast. Now obviously, yes, this does not work when the plug is unplugged. There is no current reading from the kilowatt showing any usage, amperage or wattage coming out of it. Okay, which is assumed because the hot wire is not in use. But what's interesting is there is now voltage that is accumulating in the tate circuit. So I can now come and I can short it. Remember, the switch is still off. I can go over to the tate and short it over and over and over again. Obviously the light cuts out when the discharge happens. Now this is on the output side of the tate, whereas the light is in series with the ground wire on the input. You don't have any discharge. You do get a slight fluctuation in the light by shorting right there. There's some decent energy here. The reactance bank at the same time, some very strong arcs. Spark gap will fire on occasion when that voltage does rise enough and it does break down. Not as much when we actually have the ground wire hooked to it. But there is voltage here that's coming in from somewhere. I'm going to unhook the hot wire. I'm going to hook it to the spark gap here. You see the light lights up. It's hooked onto that side of the spark gap. It also lights up when I hook it to the other side of the spark gap. Although oscillations behave differently either way. This is quite interesting. Either side of the reactance bank will light the light as well. The other side of the ballast, the common wire to ground through that light, also lights it. So the question is, where is this energy coming from? Are we getting an actual difference of positive potential through this ballast from the neutral wire in relation to the earth rod? I hook it back up. Like I said, I turn it on, tate starts functioning, nothing comes from the ground rod. Even like during the discharge, you would think there'd be some flickering or something, but it's not until I turn it off that the light comes back on. You see, light comes on when I turn it off. Lights on, spark gap fires, everything behaves normally. When I turn it off, so now what I'm going to show you is, now that it's off, I'm going to unhook this, and I got to go get my voltmeter to really measure this, but I'm going to take this and I'm just going to tap it to the side of this coil here.